Okay, now, as you can see by the title up there, there's two real, I guess, schools of thought of the way you can teach this trig unit, and is special triangles and the unit circle. Now, I don't spend any time on special triangles. The time that I'm getting you guys to commit to is your unit circle, because not sometimes, often knowing both, students do worse because they get the two mixed up. Okay? The unit circle, and that's why you should all have a blank unit circle on your desk right now, because the unit circle is something you have to be able to like polish off in a minute. Okay? And I'm not exaggerating by the minute thing. It has to be, okay guys, you can open your diplomas now, and you're drawing a unit circle. And then you're done. Yeah, no, the first questions will not be trig. Okay, it's just money in the bank for later. So when you're doing questions, you can check it with your unit circle and make sure it's right. So here's how you can do a unit circle in under a minute. Now, I'm going to teach it with you, so it's going to take us 2 minutes. But there's notes I want to make on the bottom of your unit circle, just so you're not going to write this probably every time you do one of these, but you should know it. Now, so we're at the bottom of our unit circle. Are we missing some in your row, right? No? Good. Okay, so we're going to, our 30, every 30 degrees is a pi over 6. Okay? And every 45 degrees is a pi over 4. The other thing is we have our coordinates will always be x, comma, y, which is the same thing as cos, comma, cos theta, comma, sine theta. Okay, and tan theta equals y over x, which equals sine theta over cos theta. Okay, now it's important that you know these, and you know quadrant 1 very well. So this is how you should do a unit circle quick. Okay, so the first thing you do is your pi over 6s. Okay, so every 30 degrees. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, no ruler. I'm doing it just like you're doing it. Now, on them, I want you just to label. That's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, 12 pi over 6. Okay, so you get all those in. And I don't actually reduce them. But you need to know that 2 pi over 6 is the same thing as pi over 3. And why don't I reduce them? So I remember, I can count better by ones, and I can reduce well enough. Now, let's do all the 45. So I'll do those. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So I will label those as, in red, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay? See, I've completed the entire unit circle, and you can do that in under a minute. That's not a bad investment when the biggest chunk of your diploma is trig. We're doing 2 whole units on it. You need to know your unit circle for the entire time. And I can guarantee you that if you use this on one question, you'll get your minute back. Okay? So it is an investment that you will get later. Did any of you guys ever buy those ski passes to Armit and Sunshine? They're like $75 or something. No, how much are they? I can't remember. I got one for Christmas this year. But you get your first time skiing for free. And it's almost like, the pass almost like, it's $2 more than if I just went skiing once. So it's like a no-brainer. And then the second time you get 15% off, and then there's third time, and the fourth time you go free again, right? So this is like, yeah, buying the pass. Yeah, it's inconvenient. You have to go. It's so much easier to just go to the hill while you're there, right? But if you get this pass from, they sell them at Costco, they almost pay for themselves the very first time you use it. This will pay for itself the first time you use it. Now, quadrant 1, know your coordinates. The coordinates are 1, 0, root 3 over 2, 1/2, root 2 over 2, root 2 over 2. Well, I can't, or else then I can't. But you guys should know your unit circle by now. You had to know them last year too, right? And 1/2, root 3 over 2, and 0, 1. Okay, do you guys remember your tans? Starts at 0, root 3 over 3, 1, root 3, and undefined. Okay, and if you really want, you can write cosine tan, cosine tan. Okay, and then the last thing I would have on here is the cast rule. Okay, C A S T. Now, if you reflect this over the y-axis, that's x's changing to negative x's, right? And that's what would happen. But it also shows up in the cast rule, right? Because only sine is positive in quadrant 2. So you would just reflect all the rest. I wouldn't write out all the rest when it was time to get that unit circle done on the diploma. Okay? But if you have time, you can like, if you're watching TV, anytime there's a commercial, just see how fast the unit circle, right? They say it takes 1,000 hours to master, like if you wanted to learn a game of golf, you'd have to do 1,000 hours, right? Like that's the whole Tiger Woods thing. His dad knew this, and who knows if he was a prodigy or not, but his dad would hit golf balls when he was in, he would watch his dad hit golf balls in his high chair. You know, like his dad started in that early, and just as an experiment, I think, to see what would happen. Turned out kind of okay. He screwed it up later, but he had a good ride. Now, why do I put everything over 6? Okay. Now, I don't know how many of you guys, you know, are work in the garage or work with your dad on engines or whatever. But if you know the imperial system, and this used to be so stressful when you're like 5 years old and your dad's like, he's got the 7/16 wrench and he's under the truck, right? And he's just I need the next size bigger, right? And you go into the toolbox, you're like, like what's the next size bigger? You're like holding them up to each other, right? The two ends, see which one is bigger, because the size bigger than 7/16 is a half. Now, when you're 5 years old and you're looking in a toolbox, how on earth would you know? Right? Yeah, you hold them up to each other. That's the only, but if you understand that all of your wrenches are over 16, so a 7/16, the next size wrench would be 8/16, right? 8/16 is a half. Then the next wrench is a 9/16. See, a 7/16 and a 9/16 are in that toolbox. But how do you know the one in the middle? It's like, like you're looking in a toolbox, you have no idea, right? When you're like a little kid, 1/2 it's not intuitive. And that's actually one of the reasons they got rid of the metric system, or sorry, the imperial system, except for the states. But it's because it was so confusing to people, the entire imperial system, right? This, if you look at the unit circle, it looks a lot more overwhelming when everything's reduced, actually, okay? But if my dad would have said, just put it over 16, everything over 16. So there's 1/16, 2/16, 3/16, 4/16. So you see every second one's reduced? But like 1/16 and 3/16 and 5/16 and 7/16 and 9/16, they're all in your toolbox. It's all the other ones that aren't in your toolbox, in, you know, the one in your head where we're supposed to be counting by ones. Why is it, right? So try and keep these, all your 45s over 4, all of your 30s over 6. You should be able to get this unit circle down in under a minute, okay? For sure 2 minutes. For sure, for sure. Okay? And you'd be surprised. If you timed yourself and just did everything, you look and go, wow, that was weird. It didn't take me that long. Okay? So I want you just to be using your brand new unit circle for today. Now let's turn to page 535. Because we know our unit circle, we're just cruising along in the book as well. Now, it should get to the point where degrees are the confusing part. Not confusing, I should say, but not as comfortable, right? It's because you're always working over 6s, over 4s, you're always thinking that way, and now they just throw sine 300 at you. So let's use our visual. Now sine 300, oops, I don't want to just do your crosshairs. Sine 300, always picture where it is. Okay, there's 270, there's sine 300, right down there. So what would that be? Because it's cos, comma, sine here, right? What's the sine down there? What is it? Not -1/2. Negative root 3 over 2. Where'd the negative come from? Does that make sense in the cast rule? Right? Because only cos b. Okay. Now, let's do next one. Cosecant 3 pi over 4. Again, this is how you should be thinking. 1, 2, 3. Cast. Because I'm thinking root 2 over 2, root 2 over 2, right? So root 2 over 2, and because it is in that quadrant, it's negative. Okay. Now, the next one, use a calculator to determine the four decimal places. The coordinates of the point on the unit circle that corresponds to 2 pi over 5. 2 pi over 5? It's not on our unit circle. And when you know your unit circle, you know what's not on your unit circle. Right? So this is why this is here. Because you can't tell me the exact. If they ever ask you for exact, they they won't ask you something that's not on the unit circle. Okay? So if you see that, I bet you'll see the 4 decimal places. You're seeing a numerical or written response question. Now, remember that to find the coordinates, it's cos 2 pi over 5 comma sine 2 pi over 5. Okay, that's how you find your actual coordinates. And that should be, if you put that in, now make sure you're in radian mode. 0.3090, comma 0.9511. Okay, 1, sorry. Now, the next question is an excellent question because it's pretty easy if you know your unit circle, which is what you kind of want, right? You want these to be easy questions if you put in the one side. So you can either put in the work, learning unit circle, or put in the work going slow every single time. Okay? Now, we have to do a visual here. We have point P and Q. They're 2 points on the unit circle. If an object rotates counterclockwise, like a second hand or a propeller, and if it goes counterclockwise from point P to point Q, what angle has it rotated? Okay? This is the impossible question if you don't know your unit circle. So, the first thing you have to do is let's figure out where is point P? Guaranteed. Which quadrant? 3? 4. Why? Because cos is positive, sine is negative. That's the only quadrant that happens, right? So, where would you expect that to be in that quadrant? 45, or a pi over 4, right? So this is point P. Now, where's point Q? Quadrant 2. Yeah, where? Where is it? 4 pi over 6 or 2 pi over 3, right? So it would be about there. Look at Q. Now, just be very careful because it's going from point P to Q. I have 2 options. I could go this way or I could go this way. It's counterclockwise. So maybe on the quiz, maybe on the written response, I'll ask you this one, but you have to be very careful of the direction. So what I need is this entire angle here from P to Q. Now, what is this angle in radians? Just this one right here. What is it? Pi over 4, right? Okay. How about this one? We already said it was 4 pi over 6, right? Now we know that's not the reduced answer, but who cares? For us, we just need a final answer. Why not? We can work with 4 pi over 6. So would it be fair to say that we're going to say it's 4 pi over 6 plus pi over 4? Okay, now how do we do that one? We have to put them both over 12. So that's 8 pi over 12 and 3 pi over 12. which is 11 pi over 12. Okay, this is a really good written response question. Really good diploma question for multiple choice. And it's not that time consuming. We're going slower in the notes, but when you're doing it yourself and you... Okay, now without using a graphing calculator, determine log 2 cos 7 pi over 4. Now, will that ever be asked to you on the diploma? The question would, but they would make the question where this wouldn't help you. So they may say it's log 2 to the 2 to the x. What is x? Okay? Now, the first thing we have to do is work with what is cos 7 pi over 4. Now, always do this, right? 1, 2, 3, 4, 5, 6, 7 pi over 4. That's where we are. What's the coordinate there? Root 2 over 2, comma, negative root 2 over 2. And we're using the cos, right? So now, this is log 2 of root 2 over 2. Now there's two ways I can solve this. Because this is division, what can I do? Because this is division, what can I do? You can turn this into log 2 to the root 2 minus log 2 to the 2. There's also another thing I can do. This is the same thing as 2 to the 1/2, right? Remember, square root? So then I can now, since those are dividing, I can subtract the bases, or subtract the exponents. That would be log 2 of, 2 to the 1/2, negative 1/2. Sorry, 1/2 minus 1, negative 1/2. What's the answer? That's a negative 1/2. It's like someone touched my focus or something because it's blurry up there. Okay, what's the answer? Negative 1/2, right? Remember? 2 to the 2 to the whatever is whatever. Okay. Let's go to page 537. Okay. Now, one thing we have to know, that for the unit circle, the radius is always 1. Now, if the radius is 1, we have to know that the equation for the unit circle, because of Pythagoras, would be x squared plus y squared equals 1 squared, which is 1. Okay? So, to find any point on the unit circle, you can use x squared plus y squared equals 1. And so if they give me the x, I can find any y coordinate on the unit circle by using Pythagoras. If they give me the y, I can find the x that belongs with it if it's on the unit circle, because that's the only circle that equals 1. Okay? No other circles, I mean, of course, there could be another one, but there's no other circles that have a radius of 1 that this would fit to. It's just the unit circle. Okay? So, how would you know if the point 1/2 is on the unit circle? Now, you can't say, oh, it's not, because it's not one of our, we don't, I mean, where's 1/2? There's root 2 over 2 over 2 over 2, but there's no 1/2. Well, can you prove it? Well, yeah, I can prove it, because if I go 1/2 squared plus 1/2 squared, it better equal 1. Why does it have to equal 1? To be on the unit circle, right? And as you'll see, 1/2 squared plus 1/2 squared is 1/4 plus 1/4, which is equals 1/2. This equals 1/2. So this does not equal 1. So the answer is no. Okay. Now, it says that the point -1/5 y lies on the unit circle. It says determine the value of y. Now, because this is here, we know that the radius equals 1. So, and it lies in quadrant 3. So if I'm in quadrant 3, will my y be positive or negative? Yes, I just noticed that right now, and I'm like, what's going on? Okay, quadrant 3. What do I know about my y value? It'll be negative, because it should be a negative x, negative y here, okay? So how do I do this? A squared plus b squared equals 1, right? So -1/5 squared plus y squared, this is supposed to equal 1. Okay, so that's 1/25 plus y squared equals 1. 1 minus 1/25 will be, I'm moving over here, so y squared equals 24/25. Okay, now, to take the square root, I'll get y to equal the square root of 24/25. Now, this is the same thing, you guys, as the square root of 24 over the square root of 25. Square root of 24, oh, sorry, what did I do bad here? This is plus minus, plus minus, plus minus. Okay? I'm still at plus minus. Square root of 24, there's a 4 in there. 4 times 6, right? 4 comes out to become a 2. Root 6 over 5. I'll just write underneath plus or minus 2 root 6 over 5. Now, plus or minus, the answer would be the minus because we're in quadrant 3. Okay, now, what if it asked, well, what is the exact value of secant theta? Okay, now this would get all confusing, right? Well, we have to know that secant's buddy is cos. Okay? So, if cos theta at this point would be what? It's x over r, but I know my x. And r is 1. So it is -1 over 5, right? So what should secant equal? -5. Or -5 over 1 if you want. Now, one thing we haven't found is what is the angle. Okay, we know that it is hanging out in quadrant 3. But what's this angle here? That's what C wants to know. Determine that angle. Okay, so this is for C. How am I supposed to find that angle? So you need to find the reference angle, which is by going, okay, second cos, and we just put in 1/5. Remember, it's always the absolute value. Now you want to be in radian mode because look at the domain, and you should get 1.3694 dot dot dot. Right. So that's just this. All we did was we figured out this. So now we have to go pi plus 1.3694, and to the nearest tenth, that is 4.5 radians. Now, if I wanted to see if this was right, I would do the same question using my sine of my new angle that I got. It's going to do two things for me. It's going to see if I did the last one right, and it's going to help me double check that I did this one right. Okay? So you always have to be thinking on a much higher level to be able to check these, and that's hopefully where we can go with these. Okay, A says determine the equation of a circle with the center at the origin and a radius of 8. So in other words, we have a circle like this, and this is 8. Okay, so it's still going to follow Pythagoras, because no matter where I go, I can always draw a triangle. No matter what happens, I can always draw a triangle to the x-axis. Okay, no matter where I go. Those are little triangles. They're all okay. So it's like the radius goes around. You can draw a triangle to the x-axis. So it is x squared plus y squared equals 8 squared. Therefore, x squared plus y squared equals 64. Now, if this point lies on this circle, how am I supposed to find B? Okay, so this would be a good numerical response, but they would probably, this one has two answers. I think sometimes they might say, and it's in quadrant 3. Okay, if they said it's in quadrant 3, I better be thinking B is negative. So I bet you it's not that one, because they never have negatives on written response, or numerical response, I should say. Now, let's do it. Okay, so I'm just going to use Pythagoras. So that is negative 4 squared plus b root 3 squared equals 64. Okay, 16 plus 3b squared equals 64. Now we can subtract 16 to both sides. Now we'll get 3b squared equals 48. Then I will divide by 3. I will get b squared to equal 16. Then I will take the square root of both. B equals plus or minus 4. Okay, so we're doing 2 to 4 A, C, E, G, and 5 to 15. Okay, now one thing that you're going to start getting confused with is the angle. When is it asking for an angle? When is it asking for a coordinate? And you need to, I guess, start, like if I gave this one cos 5 pi over 6. Now cos 5 pi over 6 would be, right, the cos value right here, which is negative root 3 over 2. But what if I asked you, find me the angle at cos negative root 3 over 2? Okay? Well, the way you would do that is first find the reference angle and then go pi minus the reference to get okay. So if the question was cos negative root 3 over 2, you would use this negative to know that you're in so when you do it this way, there will only be one answer. When you do it this way, there will be two answers actually. Where is cos negative? Where's cos negative? 2 and 3. So once I find my reference angle of pi over 6, I'll do that. And so my other one would be pi plus pi over 6, which is 7 pi over 6. So you got to wrap your head around, well, how come there's two answers? Because there's 2 times that this shows up on the unit circle. Do you know how many times cos 5 pi over 6 shows up? Once. So the answers show up twice for everybody, but there is only one cos 5 pi over 6. Okay, so these are the questions in reverse, but one takes a lot more work than the other one. And your calculator will give you this one. Well, not too exact, but this one your calculator will only give you one answer. And there's always 2. Sometimes there's 4, sometimes I shouldn't say there's always 2. There could be 1, 2, 3, or 4. Okay, so just get right at the work. The next couple days, slow down a bit, and then we will be, you know what, right in the unit exam.